Hi everyone, my name is Agnieszka and I'm a PhD student at Virginia Commonwealth University working under Professor Kostelin Damewski. Today I will be talking about my PhD research, which is software artifacts retrieval based on changesets. It is no news to anybody that modern software development happens extremely fast. In 2019 alone, GitHub reported over 87 million of merge pull requests and 10 million new users. It is a lot, and it's fair to say that as code evolves quickly, so should the tools. However, many of them still assume static approach. For instance, in the case of information retrieval models, a model is trained once and any update requires retraining the model from the very beginning, which is simply not an option for huge repositories having multiple commits throughout the day. What drives modern software development is a change, or a change set to be precise. Change sets have unique properties. First, they capture code modifications and its purpose. Secondly, each change set captures code elements that are modified together and therefore may be related. Similarly, change sets also encode how often a given program element is modified and how recent was the last modification. And finally, the continuous stream of change set represents the state of software at any specific point in time, and therefore can be used to train information retrieval model incrementally. To sum up, modern software development requires tools that can be updated rather than retrained, that can incorporate new data and reduce the influence of old information, and finally, that can capture properties that were observed to increase model performance, such as co-changed or frequently changed code. To this end, we propose to build an online information retrieval model based on changesets. The model will be built incrementally, based on a stream of commits, and allow for retrieval of software artifacts based on a query, for instance, bug report. We divide this work into three main steps. First, we plan to study how to effectively model changeset semantics. Overall, changesets encode semantics in at least three ways: at the level of each modified line, at the level of each code snippet, and finally, whole changeset has its own semantics. Our plan is to take advantage of each of these levels of granularity to build a hierarchical convolutional neural network. To create an information retrieval model based on changesets, we plan to build a neural network consisting of three layers: embedding, hierarchical CNN, and dense output layer. First, we follow standard guidelines to preprocess changesets and logs, and next we feed them into the embedding layer. To capture changeset semantics, we will use hierarchical CNN architecture, possibly similar to what was presented on the previous slide. However, depending on the model performance, its final version is still likely to change. Finally, the semantics of changesets and the logs will be combined into the dense output layer. When training, we will use changesets and their logs, since this type of data is easy to obtain at scale. Additionally, logs, which are written in natural language, are a good proxy for other natural language queries, such as bug reports. During evaluation, we will test the proposed system for the task of commit retrieval based on commit messages and based on bug reports. The result of this step is to identify design strategies that allow for capturing changesets properties. Now that we have identified how to capture semantics, we will focus on building an online model. To achieve that, we will explore three scenarios. First, we will try a naive approach where we simply build the model one changeset at a time. Changesets are presented to the model in the order they were committed to a repository. Second approach is based on windows. A stream of commits will be divided into overlapping mini-batches, and each mini-batch will be presented to the model once. Finally, we plan to go full machine learning and try to incorporate hedge backpropagation. This method was created specifically for training online deep learning models, and the main idea is to allow algorithms to decide which hidden layers to turn on or off to achieve better performance. Similarly, as before, we plan to repeat the same experiments as in previous stage, comparing model performance in terms of accuracy and time. Additionally, for the task of bug localization, we plan to compare to the state-of-the-art methods. Finally, we would like to explore how to extend the initial model with other software-related information. One source of such information are bug reports. Although we evaluate the model for the task of bug localization, the model has no explicit knowledge of bug reports and their fixing changesets. To this end, we propose to build a separate, simple information retrieval model based only on bug reports, and construct a function that translates between the space of bug reports model and the space of the changeset model. The function can be trained on the historical data when such data is available and contribute to the final prediction. In a result, we would be able to introduce historical data to our model in the form of an independent module that can be added when sufficient data is available. And that's all. Thank you so much. Bye.